Thanks for the organizers for inviting me. Very exciting to be part of Alta COP30. For us climate scientists, it's actually a daily bread and butter to think about where we are in time and space, analyzing information on weather and climate in time and space and how this is interconnected. We do this all the time. And so Friday, the World Met Organization published a special global state of the climate for COP30, saying what 2025 is like and where we're heading, and some of this was already mentioned before. So some of these points here are all part of this sort of lengthy statement, but what I was particularly watching over the last few days is what's actually happening in the Philippines. They already have 21 tropical cyclones this year alone coming through, damaging the country. But with regard to the update for 2025, we see that we are 1.42 degrees plus minus 0.21 above pre-industrial average. And so the World Met Organization actually requires to be above 1.5, not just for a month or so. So this is why this is an average over several years. But ocean heat content, similar high as last year, sea level rise even accelerating, glaciers continue to see strong losses, Arctic sea ice extent the lowest on record, and extreme weather and climate events all over the place this year, just as it was last year. So this is what was just mentioned in the previous talk. We are on the way to be the second warmest year on record. So when will we pass 1.5 degrees, as we haven't done so officially, at least not with the World Met Organization? And what I wanted to show you here is with every IPCC assessment report, you have these model experiments that everything is based on just ahead of IPCC. And then now the key word is overshooting. So we're going to overshoot 1.5. This is more or less a fact. And the hope is we're going to come down at some time in the future. And we will land at a point that hopefully will be at around or even below 1.5, given the NDCs that are happening all around the world. On the right-hand side, on the top right, on the furthest right, you actually see the estimated temperature curves of these overshooting scenarios. So over here, everything is overshooting and coming down, except maybe one of the worst case scenarios, because we don't know what the future is like. But overshooting is the new buzzword. The next IPCC report will be all about what happens in these overshoot scenarios and what are the impacts. And so what I want to do now is tell you the story about some of the science that I'm doing in our center in Singapore. So I'm actually working for the government. It's a government institute. And how this relates to what the days and the weather will be like in the future. How does it affect your lives? Now, as it so happens, we conducted one of the highest resolution future climate change projections for Southeast Asia over the last 5 years. And last year, we published them, and this was work done for the Singapore government, but it extends much broader. We actually did an analysis that went all the way out across the big domain of Southeast Asia, where we're now currently collaborating and talking to a lot of our neighboring countries in ASEAN and helping them to put together their national projections. But specifically for Singapore, we did a lot of downscaling, it's called, to very high resolution information at 2 kilometer resolution information for the government, so they could understand for the very first time how the climate is different in the future between East and West Singapore or North and South, and what happens around. And it included sea level rise. So we have this data, and I want to show you a little bit about the science of extremes in the future, and then what does it mean in terms of the daily life. So I'll start with what we call hotter days. So think about the top 5% hottest day in every year. That would be about a fortnight, 15 days or so so the hottest 15 days in the year, and what happens to that number in the future. And because we have the data, we can actually see what happens. On the right hand side, you see the change. The blue is the low scenario that would have kept us at 1.5 degrees at the end of this century. And then you have a medium scenario in yellow, and in red, the worst case scenario. And so you can see there's actually in the region a number of countries that have sort of a fairly modest increase of these what we call hotter days, but there's quite a lot of countries in Southeast Asia, including Singapore actually, where there will be a very strong increase. So the key message is these hotter days are going to become the norm in the future. What happens then with heat wave and intense heat waves? And so we did a lot of work, and you can look at all these different characteristics of heat waves. What I want to show here is just the change in the length of heat waves and the colors sort of show the days, with red indicating above 50 days longer than there are now. So across all of Southeast Asia, we can see that there is an increase of 120 heat wave days per year, and so they persist for at least 40 days on average or longer, and in general are 4 degrees hotter than now. So the heat waves, especially in other parts of Southeast Asia, for Singapore itself, because we're in such a humid country, heat wave has a completely different meaning, because for us this is associated with strong heat stress, humidity, and no winds. Okay, so what does it mean for you then? So more frequent in intense heat waves, we have more days where outdoor and indoor wear events are much more dangerous, and so you have to think about whether you do this at all. The hours have to change. We may see more air pollution, because as we get longer droughts, for example, we see more transboundary haze likelihood, and therefore the air may deteriorate, so impact on asthma and respiratory problems, but also the disease-carrying insects. So the temperature changes and rainfall changes will also change the occurrence of vector-borne diseases, and therefore this will also have impacts in Southeast Asia, and including Singapore. Now, with regard to food and your groceries, so the greater variability in the crop yields because of the longer droughts and the floods in between, that you have more frequent local storages or price spikes depending on where the food is coming from. In Singapore, we know it's importing over 90% of its food, but also supply chain disruptions from extreme weather. So whether the ports are being affected, and therefore you don't get the same supply line. Now, in terms of what can be grown locally, some regions actually use the suitability of growing further crops. So in my institute, we also looked at specifically rice, and of course rice is mostly imported in Singapore. So what are the key import countries? How is climate change impacting the rice production in these countries, and what does it mean in the future? Now, we also look at what we call urban heat island effect. So we know that we have the global warming signal from the global climate change, but if you live in an urban environment, there's an enhanced warming due to the fact that you're surrounded by lots of big concrete blocks, which are basically heat sinks, and they keep emitting the heat at night. So there's a continuous warming of the atmosphere in an urban environment above and beyond what is the general global climate change signal. So therefore, in Singapore, the government is very, very interested in urban heat and what can be done to cool Singapore less or make it warming less. So we are involved in this project. We actually, for this, you need to go even further down with your information, down to 100 meters or more, which we're doing. But the key thing the government is interested in is what happens in mitigation scenarios. So if we plant another 1 million trees and then run the same system, or you switch off all the cars all to electric, or other ways for the government to turn down the heat in terms of the future urban warming. So we're involved in this, and this will probably be a growing body of work. Heat stress. I mentioned this before. So in terms of the wet bulb globe temperature, which is the combination of actually those 4 variables: temperature, humidity, winds, and solar radiation. And this is what really feels where you feel the impact of the heat. So especially with outdoor work capacity, that is a huge question mark on how this is going to happen in the future as areas, urban areas, become very, very hot and humid. The energy demand for cooling. So the government now has to find out what happens to the standard cooling systems if it gets even hotter and more humid, but also bigger expenditures for disaster response in coastal defense and climate adaptation, and migration pressures. So these are all topics that are relating to more extreme weather happening in the future. Quickly want to mention, this is something not particular for Singapore, but tropical cyclone, as we just saw what's happening in the Philippines, we see, just like in IPCC in general, but they couldn't actually show it with data, is there's overall less tropical cyclones, but the strong ones are going to increase. The frequency of the strong tropical cyclone is going to increase. And we can see this is an example where we helped analyzing the data, especially for the case of Vietnam. Now, with regard to extreme rainfall, the changes are more seasonal. So there's no sort of story on the annual averages. So you look in wet season, dry season rainfall, how is this changing? And we see the wet seasons tend to get wetter, and the dry seasons tend to get drier. But also duration and frequency of drought periods are increasing, and so we see as impacts and more frequent frequent droughts in some regions with water restrictions. So limiting what you can do, how much water you have available. More intense storms and flooding may also result in homes, roads, and sewage systems being out of work. Increased property damage, more frequent travel disruption, and also the urban heat island getting worse. All of these will have strong impacts on your daily life. Sea level rise, and so we delivered sea level rise projections as part of this, but we also looked across Southeast Asia what happens. And with regard to sea level rise, we know it's regionally very, very different. And in fact, there's a large uncertainty around what's happening with Antarctic sea ice. And this is currently the biggest uncertainty in the system. But if it happens, or Greenland ice sheets are melting, this could sort of turn into a tipping point story where you see massive amounts of sea level change. The other uncertainty is, of course, with regard to what we call vertical land motion. So this is subsidence in big cities like we've seen in Manila and Bangkok already, and this is why their projected changes in sea level rise are so much higher than, for example, ours in Singapore. So Singapore is very much like the global average. So more visual adaptation measures, you will see, so flood barriers, grazed homes, shaded bus stops, all these different measures like rooftop gardens, drought-tolerant landscapes, changing shopping habits in terms of seasonal produce being different, and lifestyle shifts because of rescheduling of activities because of the heat. Now, we know this is regionally very different. So it's not the same for every country, not the same for every city, every region. So it's also depends on wealthier areas versus more poor areas, because there we know it's a big confounder, the economic wealth. So bottom line, staying above 1.5 degrees there's a new normal that includes more frequent extremes that touch daily life in visible cumulative ways. So whether it's higher heat, more smoke, storms, strained food and water system, economic pressure, stronger incentives to adapt behavior. The exact effects depend on where you are. So in Singapore, actually, we're very lucky compared to the countries around us, and how quickly mitigation and adaptation measures are implemented. And with this also, Singapore is actually a lot better place to be. And this is why I agree Singapore should be seen as a leader. This is the place where we can show the other countries in Southeast Asia what could be done if we work together. So my good news story is on the last slide. So try to look on the brighter side. So focus on what we need to inform our decisions in the best possible way. And for me, where I come from, this is good data and good science, actually good fundamental science. And so one thing I see with everything that's happening and the really strong focus on mitigation and adaptation, which is absolutely necessary, is that it comes as a cost to the fundamental science. But the view that the fundamental science is done and dusted is wrong. There's so many things that we don't know yet properly in the fundamental science. So we need to support fundamental science, understand the value of real data, understand the concept of uncertainties that comes with projections, and also understand the fact that the climate science is here to support all, make use of it. So, for example, in the 1992 initiation of the UNFCCC, that actually followed 2 years before the first IPCC assessment report. And that's why UNFCCC was actually founded, is because of the science that was done 2 years before. And they thought, we need this now. Thanks.